Okay, in this video we're going to show the T-probe in use. So we've got the laser tracker, the T-probe in the field of view. You can see it graphically moving around in SA when John picks it up. We're not aligned to the CAD, so we're going to align the instrument to the CAD by using a 3-circle alignment. So we're going to use this circle and these 2 smaller ones, and then we're going to align using that technique. Okay, so I've kind of defined them in the kind of inspection list already. So we're going to press play. And then John is going to measure with the T-probe on the top face as shown on the screen.
So the good thing about the T-probe is that we can use it much like you would a portable measuring arm. So the actual tip that you can see here by my finger is a 6mm diameter tip, which you can see at the top of the screen and the software is identified. So it's the tip that's doing the measuring, but it's actually the face of the T-probe. I can't really show you because the tracker's locked on, but it's the face of the T-probe that the tracker is looking at. So what that really means, the main benefit of a T-probe is that you can measure features that are out of sight of the laser tracker, and as long as the tracker can see the actual black face of the T-probe, you can do the measuring with the tip. So simply measuring a top plane, we just push this little red button, or one of the 4 red buttons on the side of the T-probe. Take 1 point, so you get some audio feedback. It beeps at you if you've taken a good point. So move it on to another point. That's 2, 3, and 4 points on the plane. So we're going to switch from that plane now into the actual hole itself. So this is where the T-probe comes into its own. I can use my finger to push the tip against the feature. Take 1 point, 2.
So it's counted up 2 of 2, so we're going to do 4 points.
3. Okay, 4.
So it's jumped on to the next feature, and we can see on the CAD that it's this. It's the one, the same end as the slot. Just need to make sure you see it's highlighted in the slot. Yeah.
Okay. So top plane. 1. Pretty quick, and then inside the circle.
Okay. The opposite rebate. Measure it into the hole now. Okay, so if we zoom out on the screen now, we can see the instrument doesn't know where it is relative to the CAD. We've got some planes and some circles that have been projected up because that's the way we defined it. And we're going to right click on the instrument. We're going to locate. Sorry, we're going to locate. Let's right click there. So yeah, it was still trapping into another relationship underneath. So we're going to locate using nominal geometry relationships. And it's asking us what relationships do we want to use. So we're going to use the 3 circles. We're going to do the 3-circle alignment. So the 80mm hole and the 2 2-in holes. We do OK. And then we get this kind of best fit window coming up. So 3 circles, run the algorithm, and then we get the deviation. So we've got 12 microns in the first column, 10, then 2. So really good alignment. If we apply transformation, we can see the tracker and all the points move relative. Okay, let's check the alignment, similar to what we did with the reflector. So we're going to right click on the CAD and add a watch window. So wherever we move the T-probe, maybe we make the CAD see-through as well. So wherever John puts the T-probe, we can see the deviation, either in holes or, yeah, so we're in a cylinder there and we're just checking graphically to see where we are.
That's a really good alignment.
Okay, so let's close that off, and finally we're just going to measure the front face. We'll double click, so we can see we're going to measure this front face, and we're going to use a spatial scan mode. So if you put it onto the front face and press this, so it's like the streaming points, again similar to what we did with the reflector. This time we're going to do it with the probe. Okay, and if we measure again, so if you press button A actually, John, if you run it on the surface now, so we can see the points coming in, and the vectors are relatively small because the alignment was so kind of good. So as John's moving it along the surface, you can see that it's updated on the right, the vectors are appearing, and yeah, that'll do. So we'll stop it there. Okay. So similar to what we did with the reflector, I'll just minimize this video. We'll stop that, trap it in. We'll maybe add some call outs. So we've got the holes, the planes. We can arrange these quickly. Similar to last time, we can right click, generate quick report, PDF, and then we've got the screen grab again and all the information from all the holes and the planes, and that's the scan. So we get a lot of information. We're not seeing anything red because we're in tolerance. Okay, so that's the T-probe and spatial analyzer. I think John's going to...
Just one quick thing, if we could go back to the video on the screen, I'm not sure if that's possible. There we go. So, keeping it in video as well, you can see the indication lights at the top of the T-probe and you can hear the beeping. That's because the tracker isn't looking squarely on at the T-probe. So if I rotate it back into view, so you've got infinite rotation in this angle, you've got plus or minus 45 degrees in tilt and roll. One of the other things that's great about the T-probe that we haven't really discussed, if I just break the beam and come into the camera view, you can see here that we've got a little quick release lever. If we just turn that, we can take the probe off. This one here, you can see we've built up is a 6mm tip and maybe 150mm overall stylus length. So you can have any number of these styli available to use with the T-probe. The moment you put it back onto the T-probe, rotate the handle, connect back onto the tracker, you'll see that the tracker automatically recognises what tip we've added and we're good to measure again. So that's one of the real advantages of the T-probe. We can go all the way from a scribe tip, which is effectively a 0 diameter, all the way up to an 1.5 inch diameter sort of ceramic sphere to mimic points where you would put an 1.5 inch reflector. So it's a really versatile tool. You can have any length up to a couple of meters long if you really need to go that far, but we would recommend a maximum stylus length of up to maybe 400mm, and they're really great for reaching inside parts that you wouldn't be able to see with a reflector, and long shafts, things like that. So really versatile tool. 6 degrees of freedom technology, which is why it's a 960 tracker. So you can't use the T-probe with a 930 tracker. The 930 is 3D only. You move on to the 960 tracker to be able to use the T-probe and the T-scan. I think in the next video we're going to show you the T-scan working, similar kind of principle, and again I think we'll probably use a similar demo block just to show you how that measures.